Okay, back on the tangent. Please turn your books to page 203. We're going to go over the distribution of sample means. Boy, this is going to be pure learning excitement for you. I'm going to try to make this as least painful as I possibly can, but let's see what we can actually do here. So, in this situation, if you turn to page 203, let's pretend, just for the sake of argument, that we have a population with only 4 scores in it. The 4 scores are 2, 4, 6, and 8. 2, 4, 6, and 8. Now, if I asked you with that population what the mean of those 4 scores were, could you add it up and figure it out? Hopefully you would get a mu value of 5. You could also figure out a standard deviation, but we don't want to do that here because we're trying to have a good time here. So, in this situation, if you have a population of 4 scores and you get the mean is 5. The problem with statistics is we almost never have the whole population. And if we do have the whole population, it's never 4 scores. The population is 20, 30, 40, hundreds of scores. So when we run our statistics, we almost always use samples. And so we're going to do a little exercise here when the population is 4 and we get all possible samples with replacement when n equals 2. We're kind of doing this as a little proof exercise. If you look on page 204 of your book, you will see that it actually has a distribution of all the possible samples when you have 2 scores. Turns out there are a total of 16 samples you can get. So if you sample with replacement, if you have all these 4 scores in a bag, and if when you take one out you can put another one back, the first possible sample you can get is a sample where the number pulled out is a 2, you put it back and you get a 2 again. So the first sample is a 2 and a 2. The sample mean of that is a 2. The next sample is you pull out a 2 and then you pull out a 4. The mean of that is a 3. Then you get 2, 6. Then you get 2, 8. Then you can start drawing 4s, 4, 2, 4, 4, 4, 6, 4, 8. Then starting with sample 9, you could pull out a 6 first. 6, 2, 6, 4, 6, 6, 6, 8. And then you could draw samples with an 8, 8, 2, 8, 4, 8, 6, 8, 8. So if you have a population with 4 scores and you get all the possible samples when n equals 2, you will get 16 total samples. The next thing we would do is make a chart out of all the possible sample means. You would make a chart of all the possible sample means. Notice there are 16 sample means on the far right hand column, but they're really only a total of, 1, 2, 3, 4, 5, 6, 7 different means you can get. So if you look on figure 7.2, there is one sample mean where you get a 2. That's where you draw a 2 and a 2. There are 2 examples where you get a mean of 3. That's where you have the 2, 4, the 4, 2. There are 3 examples where you get a sample mean of 4. There are 4 different examples where you can get a sample mean of 5. There are 3 examples of a sample mean of 6, 2 examples of a sample mean of 7, and 1 example, if you draw 8 and 8, where you get a sample mean of 8. Now, if you were to make a drawing of that thing, how does that shape look? Well, if anybody ever asks you what the shape of something looks, you only have one answer. That looks like a normal distribution. That's exactly the way. This is a curve. If you make a curve here, it's a distribution, not of just scores, but this is a distribution of sample means. The shape of the distribution of sample means it has a normal shape. You think that's good news for us? It is. It's very good news for us that we have a normal distribution if we get all possible sample means when n equals 2. The other question I have for you, and it's in 2b, what is the mean of the distribution of sample means? What's the middle score there? Well, the mean of the distribution of sample means is 5. That should make a little bit of sense for you. The mean of the distribution of sample means is 5. What was the mean of the population? 5. So we've actually done a little proof here. The mean of the distribution of sample means is actually the population mean. And in this case it is 5. The shape of the distribution of sample means is normal, even if you have 4 scores and you sample all the possible sample means when n equals 2. So this is good news for us. The problem we have, and actually on page 205, we've actually just proven something called the central limit theorem on page 205. For any population with a mean and a standard d, the distribution of sample means will basically have a normal shape. And that's the central limit theorem. There's some other details there, but you don't need to worry about them right now very much. But the idea is, and the problem we have now, we did a population of 4 and all the possible sample means when n equals 2. The problem is when we run a study, do we get all the possible sample means? No, we just get 1. And so what we really want is when we get 1 sample, we hope we can get a sample mean that's very close to the population mean. The standard error of the mean, the denominator for that z-test, is the distance between the sample mean you get and the true population mean. And so what we really want is we want to make sure that if we're using a sample, that we really get a lot of people in that sample, because then the denominator of the z-test will be small, and that denominator is measuring the distance between the sample mean you get and the true population mean. So we want a sample size that is very large. If you go back up to that z-score formula, the idea is in B2, the denominator, and the reason we went through this tangent, the denominator is the sigma over the square root of n. That is called the standard error of the mean. It measures the distance between your sample mean and the population mean. The higher your sample size is, the smaller that number will be, and that's a good thing, because that means the distance between your sample mean and the population mean is going to be close. So we want the denominator in the new z-score formula to be low. That denominator will be low if we have a large sample size. Whew! Well, that was a bit of a recording. Thanks for your attention. Look at the book, try to put your notes together, and get this stuff down. Thank you. Bye-bye.